Hi everyone, welcome back to my channel. In this video, we are to factorize another special case that is the perfect square. Let's determine a, b, and c in the question. A is 1, b is 10, c is 25. We are to create a box. The first line, the product of two numbers, should give you a times c, 1 times 25, should give you 25. And the sum of two numbers should get you b, so 10. Think of a combination that satisfies this condition. If you were to look at this 25, I believe 5 times 5 will give you 25. And fortunately, that 5 plus 5 gives you 10. We are to break down the linear term, that is 10, into the two numbers we find, 5 and 5, attach x on each number, and copy everything else back, plus and plus 25. We are to apply grouping technique. You are to group two terms in a pair and factorize the highest common factor in each parenthesis. The first parenthesis, I believe you can factorize x. That leaves you x plus 5 inside the parenthesis, plus sign. The second parenthesis, I believe you can factor out a 5, leaving you x plus 5 inside the parenthesis. Let's apply the distributive property where you have x plus 5 in common. And in another parenthesis, you are to put x and 5. Don't forget the plus sign. Let's look at the factored form we have on the right, where you have x plus 5 being multiplied with x plus 5. You can see that x plus 5 is being repeatedly multiplied for 2 times. We are to rewrite this in terms of exponent. That is same as x plus 5 being multiplied for 2 times with the exponent 2. And this is the reason we call this special case as perfect square, given the length as the expression inside the parenthesis x plus 5, you are to square it to get the area of a square. We are to generalize this pattern before we do anything. If you are to refer to the 25 here, we are to convert this 25 in terms of the square number, that is 5 squared. And let's start. In place of x, I'm going to put a in general. So a squared plus, we leave the 10x first. And in place of 5, I'm going to put b. So b squared. And on the right, a plus b inside the parentheses squared. And let's look at the 10x we have. I'm going to break the 10 apart into 2 times 5. And now 2 remains as your 2. 5, remember, that is b, x, a. Shortcut method, when you see a perfect square, a squared plus 2ab plus b squared, you can directly convert that into a plus b inside the parentheses squared. Let's have a look at this example. Let's look at the first term. We have 4a squared. If you are to look at this 4, we can rewrite the 4 in terms of a square number, that is 2 squared and a squared. Let's recall the exponent rule we have, where you have a to the power of n, b to the power of n is equal to, you can factorize the power n, they have n in common, and put ab, two bases inside the parentheses. In this case, I believe you have the power 2 in common. So in place of n, you factorize the 2 outside the parentheses, and you have two bases. They are 2a. Correspondingly, I believe your 4a squared turns to 2a inside the parentheses squared. In a similar way, let's look at the third term, and if we can convert that in the form of something squared. You have 49 v squared. Let's first look at the 49. 49 is 7 squared, perfect. and b squared, and they have the power 2 in common. You can factorize the power 2, and inside the parentheses, put the two bases, 7 and b, and fortunately that you turned this 49b squared into 7b inside the parentheses squared. Let's recall your perfect square formula. I believe you should have a squared plus 2ab plus b squared is equal to a plus b inside the parentheses squared. So if you are to look at these 2a inside the parentheses, in this case is a form of a, and if you are to look at the 7b inside the parentheses, this is in the form of b. So before we turn that into the factor form using the shortcut method, we are to determine whether this 28ab, the middle term, is in the form of 2ab. 2ab, you have the 2, and let's look at the a in our case, that is 2a, and let's look at b in this case, that is 7b. So we are to find the answer. 2 times 2 gives you 4, times 7 gives you 28ab. If you are to match 28ab and 28ab, indeed they are the same term. So we found that this is in the form of perfect square. This 28ab is in the form of 2ab. We now can apply the shortcut method. If you are look at the right of the equation, a plus b, so in place of a, you put your a, in this case, that is 2a, plus remain as plus. And if you are to look at b, we are to put the b, in this case, that is 7b, together inside the parentheses, and then squared. Now let's look at the second version of the perfect square, where you have the minus sign attached to your linear term. And let me give you the factorized form directly, and we are to find the pattern when there is a minus sign attached to your linear term, the term in the middle. If you are to factorize using the box method, you should get x minus 5 times x minus 5. We are to rewrite this in terms of exponent. If you are to look at this, that x minus 5 is being repeatedly multiplied by 2 times, so we are to put the power 2. We are to generalize the pattern, so in place of x, you put a squared. We leave the minus 10x alone first, and we look at the 25. 25, we can rewrite the 25 in terms of a square number, that is 5 squared. In place of 5, you are to put b, so b squared equal sign x a 5b in a parenthesis squared. The key thing I would like to remind you is this. If you are to look at the minus sign attached to your linear term, and this minus sign we always match with the minus sign on the right in between a and b. The last step, we are to break the 10 apart. 2 times 5 gives you 10, and 2 remains as 2. 5, remember, we took it as b, so b, x as a, and the plus sign in between 2ab and b squared. This is the general form you have, and you should always remember this. If there is a minus sign attached to your linear term, you must always match that on the right. Let's look at the last example we have, where you have a minus sign attached to the linear term. So let's first look at the first term and the third term. We are to rewrite 16m squared in terms of something squared. 16m squared, we are to look at the 16, the number. We can rewrite 16 as 4 squared, m squared. Let's recall our product rule in exponent, a to the power of n multiplied by b to the power of n. You can factorize the power n and put a parenthesis in between a and b, the two bases you have. In this case, you have the power 2 in common. Factorize the power 2, leaving you the two bases inside the parentheses, that is 4m. 4m inside the parentheses squared. In a similar way, we are to deal with the third term, that is 9n squared. Let's first look at the 9. 9 can be expressed in terms of 3 squared, n squared, power 2 in common. So factorize the power 2, leave the two bases 3 and n inside the parentheses. So 3n inside the parentheses squared. Let's recall the another version of the perfect square we have. A squared, remember, minus sign attached to the linear term, 2ab plus b squared. On the other side, you have a and b as the base inside the parentheses, but always remember that you have the minus sign in between. You are to always match the sign that is attached to the linear term, so minus squared. We are now to determine whether this 24mn, ignoring the sign first, if is 2ab. And we have a as 4m and b as 3n. So 2ab, 2 times 4m times 3n, and let's see if that gives us 24mn. 2 times 4 gives you 8, times 3 gives you 24, and attach m and n. So indeed, this 24 matches with the 24 in the question. Therefore, this is indeed another version of perfect square in which there is a minus sign attached to your linear term. Let's use the formula on the right. We find a, that is 4m. We find b, that is 3n. Minus in between, match with the sign attached to the linear term. Everything squared to the power 2. If you like this video, don't forget to subscribe.